In this video, we're going to be focusing on sketches within trigonometry. So first things first, you want to make sure the trig ratio is on its own. So sine, cos, or tan needs to be on its own, and it is over here. So I'm going to move on to step number 2 of the process. I'm going to draw a little cast diagram close by and decide what quadrant I'm working in. With the cast diagram, it needs to meet both conditions mentioned in the question. So over here we can see tan is positive. So I'm going to tick the 2 quadrants where tan is positive. A stands for all is positive, so it's over in the A quadrant, and T stands for tan is positive, so I'm going to tick those 2 quadrants. And now we look at the second condition. X is an element starting at 180, ending at 270. So from 180 to 270 is in this quadrant here. And then we work in the quadrant with 2 ticks. So I'm going to draw an expanded view of this quadrant. And when I draw the triangle, you must think of the bow tie on how to draw the triangle. The bow tie just tells you to draw the triangle like this and not like this. So let's go ahead and draw our triangle like that. And the angle x, you always start on the positive x-axis and you go anti-clockwise until you touch your hypotenuse. Then we always use the angle closest to the origin as our reference angle. And now I'm going to start filling in the sides of my triangle. So I look at my trig ratio here and I think of Sokotoa. Okay, we are working with tan in this question. So the one on top is the opposite, and the one at the bottom is the adjacent. So opposite to my angle will be the 3, and adjacent to my angle will be the 4. But you've got to be a bit careful. Look where you are on the Cartesian plane. This is the negative x-axis, and you're going under. So that's the negative y-axis. So both of these need a negative in front of them. And once that's out the way, we are going to work out the missing side using Pythagoras. So we're going to say our hypotenuse squared equals. Now our hypotenuse, we give it the name of r. R is short for radius. So the radius squared will equal the other 2 sides squared, and you add them together. Pop that in the calculator and it will give you 25, and then you square root 25, and you've got 2 possible answers for r. You could either be plus 5 or it could either be minus 5. And the rule with these sketches is your hypotenuse can only be positive. You can never ever have a negative hypotenuse. So we're going to select the positive version of the radius. And then we chuck that on the sketch at the same time. And now we're finally actually ready to answer this question. So to get the value of sine x, I just use so with my sketch. So let's go ahead and do that. Okay, so the opposite is negative 3 and the hypotenuse is 5. So it's just negative 3 over 5, and then we've officially finished this question. So let's have a quick look at where these 3 marks are coming from. So we get 1 mark for our sketch, 1 mark for the correct value of the radius, and 1 mark for our answer for sine x. Moving on to 6.1.2, a small little double angle over here. We don't have 2x in our sketch, so we need to somehow transform this to something with only x and not 2x. So we're going to use the double angles to accomplish that. Very luckily, with our double angles, it is on the formula sheet, and we only have 1 double angle for sine of 2 theta, or in this case 2x. So we're going to transform that thing into this using the double angle identities. So let's go ahead and make that change. Now that we made that change, we're going to fill in sine x and fill in cos x using the sketch. We can even grab sine x from here because we've done that hard work before. So I like to set up the shell of brackets like this. And then I'm just going to pop sin x into this bracket, and I'm going to pop cos x into this bracket. So sin x is minus 3 over 5, so that's going to go in this bracket. Cos x will be adjacent over hypotenuse. So adjacent to the angle is minus 4, and the hypotenuse is 5. So in this bracket it will be minus 4 over 5. And now we've just got to work out this without our calculator. So I'm going to do the two fractions first. I'm going to say top times top to get my new top, and bottom times bottom to get my new bottom. And this 2 minus 2 won't change at all. So negative 3 times negative 4 gives me that 12, and 5 times 5 gives me that 25. Now I'm going to multiply this negative 2 with this bracket. And I'm going to kind of do the same thing like top times top, bottom times bottom. But I'll convert this into a fraction first. I'm going to change this to 2 over 1. And then top times top will give me 24. Bottom times bottom will give me 25. And now I'm subtracting two fractions. Well, I can turn this into a fraction. So I'm going to get the LCD and then subtract them. So I change this to 2 over 1. And to get an LCD of 25, I'll need to multiply this 1 by 25. And whatever I do to the bottom, I need to do to the top. So 2 times 25 will give me that 50. 1 times 25 gives me that 25. So now I've got an LCD. So I'm going to like kind of morph them into one fraction. Like so. And now I can simply minus the tops. 50 minus 24 will give me 26. So my final answer will be 26 over 25. And lastly, let's have a look at where the 3 marks are coming from. So your 3 marks will come from the expansion of sine 2x with the double angle formula, the substitution inside over there, and your final answer. So I normally kind of type this line into my calculator and go straight to the answer, because it's going to waste quite a lot of time doing this mental maths over here and doing it without a calculator. So if you know where the marks are being given, you can kind of skate around that. Question 6.1.3, I see a 90 minus. The alarm bells are ringing for co-ratios. So let's grab my co-ratios quickly. Co-ratios can also be referred to as cofunctions. So I'm seeing cos of 90 minus x, which is this co-ratio here. So I'm going to change it to sine theta. And that square will just be glued on to the sine theta. And in this case, instead of a theta, it's just an x. Now we got sine x earlier, so I'm not even going to do that with my sketch. I'll just go back to my previous work. You see sine x here, we have it as minus 3 over 5. So I'll pop that into sine x's place with the square on the outside. And now I'm physically going to work this out. So if I square this, what I kind of imagine that makes my life easier is you write the bracket twice. Because when you square something, you're multiplying it by itself. And then I do my usual story, top times top, bottom times bottom. So that will give me 9 over 25, and then the minus 1 just stays behind. Okay, now same story as what we did here. You've got to get an LCD. So I'm going to turn this 1 into 1 over 1. And then times the top and bottom by 25. So it kind of morphs into this. 25 over 25. And then I kind of combine those into one fraction because I have an LCD. And then 9 minus 25 will give me negative 16. And we have arrived at the final answer. Let's have a look at where the 3 marks are coming from. So we get 1 mark for the correct use of our cofunction or co-ratio. We get 1 mark for the correct substitution of sine x. And the last mark comes from our answer. So always check this answer by typing this into your calculator, just to make sure all your working out steps are okay.